All right. So here is that program for the counter. Basically, the counter, like I said, has got 3 basic instructions. The one is an SC to set the counter. Then the next one is a CU for count up and a CD for count down. You'll see as well, which I didn't explain to you last time. You see, I've got this extra branch in the rung. So this bit that I'm setting is a marker. Basically, once it triggers the function, either the set count or the count up, I actually reset it. So I don't have to go on my VAT table and reset it myself. So I've just coded that so you can see that it will reset the bit as well, because all of these functions work on the leading edge of the 0 to 1 transition. So if it stays on 1, you have to actually switch it off before you can switch it on again to trigger again. So I've just built that reset feature that it will reset automatically. Now you can see the counter. Let me just go back. The counter is at a value of 0. So the actual counter contact, as is called, is off, which means that the function, the control you want to do on that counter is actually reverse logic. We should actually make that normally closed. But you can see the counter is on 0, so which doesn't make sense. So if I count up 1, you'll see the count here. If I just go back, sorry, to there, so I can see all of the rungs live. If I count up once, you see that count up resets itself automatically. Now you see it's counted to 1, but I actually want a preset of 5. But straight away, the counter is saying to me that it's healthy. So counting up from 0 to a number defeats the object, because when you, at 1, it's on, at 2, it's on, 3, all the way to 5. So it doesn't make sense. So technically, all counters in Siemens are countdown counters. So let me go back and set the counter using the set count here. You'll see now it's set to 5 and it's ticking happy. So now if I count down, it goes to 4. You can see the 4 somewhere here. Why is it not showing me 4 here? All right, there we go. 4 is the value. The counter values, the counter contact is still on. I count down again, it's 3. You see the 3 there, and so on and so on. And only when it gets to 0, now I'm actually at my count, but the counter contact's gone off. So remember what I said, it's reverse logic. So I think this is fast about ace. I don't think this is very clever of Siemens. So I'm not really happy with that. So let's now just go quickly to our timer circuit, which we showed the last time. I'm going to call up the next VAT table for the timer. All right, so below here, I had that timer circuit. So well, let's go and do something quickly. Let's just go down the bottom. Or let's make a timer. So I'm going to use the same bit here to trigger the timer. Then I'm going to put a timer in here. Yes, timers. I'm going to use the SD timer because that's the on timer, the on delay. And I'm going to make that S5 T-5. Is that right? Doesn't look right to me. S5 ST5 seconds. Still haven't got it right. S5 ST5 seconds. Am I not getting it right? Let me go quickly to my VAT table. I'm just going to put timer 0 in here. I'm going to just put this here. CS5 T hash. Oh my goodness. S5 T hash. T hash. Voila, we actually got it. So let's go quickly to a timer. So now if I monitor this, you see the timer is actually at 0, but I'm going to set it to 5 seconds. The moment I trigger the timer, it counts down and the timer is technically on. Okay, that was 1. So let me switch it off again. I'm just going to make another run quickly. Or I'll just put a timer 0 and we'll put that same contact here. All right, so now the timer is timed out, it's gone off again. So let me go here quickly, it's easier. If I trigger it again, yes, carry on.
I just want to ask, the reason we put the timers on the VET table is because we want to force them and unforce them. So
yes.
That's the purpose of the VET table.
Yeah, the VAT table allows you to monitor more than one thing that might not be where your view is. So you might have more than one place that the part that you're working on is affecting. So you might have this part on the actual ladder program. Your VAT table might be looking at something else. So you can, in the VAT table, it's quite nice. You can put those things and the other conditions. So you can have multiple states here that you can be monitoring. When this timer works, what else works? So you can actually see what effect it's having. So now you see the timer is now timed out and T0 is on. So it only comes on when it's technically timed out, which is correct. That is technically what we want to do. So if I reset this is on delay, and this is basically the main type of timer that we would use. My only concern is it's counting down, and that to me defeats the object of what we want to do. Okay, so that's really what I wanted to show you with the timer. Let me just go and delete this part here, and we will just work on the old ladder logic which we developed, remember, with the add block. So now we are using that UDT that we designed, and it's got a preset and an actual, and it's got it that 1 second pulse. And I want to just go back quickly to that part of the circuit just to show you one thing which I forgot to mention the last time. Okay, if you look at this rung, I'm going to switch off the comments. That M1.5, remember, is in that clock byte which we configured on the CPU. So that is coming in every second. So technically what's happening, M1.5 is on for 500 milliseconds and off for 500 milliseconds. So it gives you a nice little on and off delay. But the thing is what it is, you saw our scan time was 10 milliseconds. So technically for 50 scans, that bit is on. So we don't want to count 50 times every second. We only want to count once every second. So what this little circuit does, it says when it comes on, in the previous scan, it was off, make this contact go on. At the same time that the 1 Hertz marker 1.5 is on, it will put it on. So the next scan, when it comes around, this bit will be on, so therefore it will not trigger 1 second again. So it will only allow this 1 second flag to be on for 1 scan every second. That's called a one-shot pulse, and it works like that. You've got to have another bit to hold the previous state. Now, Siemens has got a piece of logic for that. It's called a P here. There's the P. I'm just going to quickly go on it, because what it does, it's a little bit complicated, but what it means is the marker that's on that pulse is actually the one that's remembering what the state was. So it's actually this bit here. So if I was to do this in a pulse type logic, I would use the same thing here. I would then use a P. I would use this as the marker there, but I still need this bit here. So if I just delete that one, this is doing exactly the same function as that, and we'll test it. So you can see one pulse is coming through. You can see how it's literally only pulsing that once every second. So that functionality is exactly the same as that rung that I had before. And we can just go back to our logic here, and we can test it. So if I go and reset my marker here, you see now this is the next thing about our circuit here. Because the counter is counted to 10, it hasn't got a reset mechanism. So what I actually have to do is build a little bit of logic here. When that bit goes off, so I'm going to use the not, and I'm going to do a little move. The move is another function that is quite useful. So I'm going to move 0 back into the actual. So if I now just save this again and monitor it. Because this marker, naught is not going to help. Sorry, it must be 10. Naught is right. Yes, naught is right. Silly Billy. Okay, so now you see it's reset the count back to naught. And if I go back to my VAT table is not running. Okay, oh gosh, this thing is now giving us horrible lines on it. Okay, so I don't need this, I'll just go straight here. Modify to 1, you can see now it's counting again. So it's see the 1 sec is pulsing, I hope you can see that. And at the end of 10 seconds, it gives us output. So that is the timer block that we have basically done in lieu of using a timer, one of the limited timers that a Siemens PLC is. Okay, so you guys understand this again, you can see it properly. You happy?